Hello children, welcome to the math class. Children, now we discuss about properties of factors. Children, there are 4 properties are there. First one is every non-zero number is a factor of itself. For example, 5 is a factor of 5 because 5 divided 5 equal to 1. Like this, 12 is a factor of 12. 12 divided 12 equal to 1. Then number 2. 1 is a factor of every number. For example, 1 is a factor of 5. 1 is a factor of 12. Okay. Then 3 number. Every non-zero number is a factor of 0. 5 and 12 are factor of 0 because 0 divided 5 equal to 0, 0 divided 12 equal to 0. Then 4 number, the factors of a number are finite, means limited. Okay. Then properties of multiples. 1 number, every number is a multiple of itself. 2 number, every number is a multiple of 1. Then third bit is the multiples of a number are infinite, means unlimited. Okay. So children, you remember factors 4 properties and multiples 3 properties. And children, also you remember a factor of a given number is always less than or equal to the given number. But a multiple is always greater than or equal to the given number. Then comes to even number. Children, already you know what are even numbers, what are odd numbers. A number which is a multiple of 2 is known as even number. For example, 2, 4, 6, 8, etc. Then odd numbers. A number which is not a multiple of 2 is called an odd numbers. For example, 1, 3, 5, 7, etc. Then comes to prime numbers. What are prime numbers? A number which is greater than 1 and has exactly 2 factors, 1 and the number itself, is called a prime number. For example, 2, the factors of 2 are 1 and 2. The factors of 3 are 1 and 3 because they have only 2 factors are there. So they are known as prime numbers. 2, 3, 5, 7, 11, 13, they are known as prime numbers. Then comes to composite numbers. What are composite numbers? A number which is greater than 1 and has more than 2 factors is called a composite number. For example, factors of 4, 1, 2 and 4. Then factors of 6 equal to 1, 2, 3 and 6. Here children, you mark 1 and 6 are compulsory factors. Then 2 and 3 are extra. So more than 2 factors are there. So known as composite numbers. Children, here you remember 2 is the only even prime number and the smallest one. Since 1 has only one factor, that is 1 only, it is neither a prime number, because if prime number then we necessary at least 2 factors, but 1 has only one factor, nor a composite number. So children, 1 is neither a prime number nor a composite number. There are infinite prime numbers and composite numbers. Okay, means infinite means children, you know, unlimited. There are unlimited prime numbers and composite numbers are there. Then finding prime numbers from 1 to 100. How we find? Here some steps are given, just we follow. We can find the prime numbers from 1 to 100 by following these steps. Step 1. Make a grid of numbers from 1 to 100 like this. Then step 2. As 1 is neither a prime number nor a composite number, cross it out. First you cross 1. Then step 3. Color the square with number 2 in red and cross out all its other multiples. Means first you color 2, then the multiples of 2, suppose 4, 6, 8, 10, like this you cross out. Then step 4. Color the square with number 3 in red and cross out all its other multiples. So the multiples of 3 like this. 3, 2 just 6. So you start from 6, then 9, like this you cross out all the multiples of 3. Then step 5. Color the square with number 5 in red and cross out all its other multiples. Then children, you cross out multiples of 5. Step 6. Continue this process till all the numbers are either colored or crossed out. Okay. Then children, you mark all the colored numbers are prime and the crossed out numbers except one are composite numbers. So easily you can find out now 1 to 100 which are prime numbers and which are composite numbers. So the numbers like 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, like this up to 97, you see yourself, are the prime numbers between 1 and 100. You children, remember which are prime numbers. Okay. This method is called the sieve of Eratosthenes, created by the Greek mathematician Eratosthenes. Then comes to twin primes. What are twin primes? Two prime numbers having a difference of 2 are known as twin primes. For example, 3 and 5, 5 and 7, 11, 13, 17, 19 and so on are twin primes. Children, both are prime numbers and their difference 5 minus 3 equal to 2. So, these are known as twin prime numbers. Then comes to co-primes. What are co-primes? Two numbers are said to be co-primes if they have no common factor other than 1. In other words, two natural numbers are co-primes if their HCF means highest common factor is 1. For example, 2, 3, 3, 4, 5, 6, 7, 8 and so on. Example 1. If is 16,380 a multiple of 28? Solution, you see, to check whether 16,380 is a multiple of 28 or not. We have to divide first these two numbers. If the remainder is 0, then 16,380 is a multiple of 28. So here we get remainder 0. So it is the multiple of 28. Then example 2. Express 29 as the sum of 3 odd prime numbers. 29 equal to, children, 3 odd, then prime numbers. So 19 plus 7 plus 3. These three numbers are prime and odd numbers and their sum will be 29. Okay, children, clear? Then comes to exercise 3.1. Check if the first number is a factor of the second number. Here, children, you have to check 9 and 45. In 9 table, children, you get 45. So, this is correct, or you can write yes. So, like this, you check rest numbers, then you write which are correct or which are wrong, means which are yes or no, you write. Then comes to 2 number. Express each as the sum of 3 odd prime numbers. 15. 3 plus 5 plus 7. Children, you see 3, 5, 7 are odd prime numbers. If we add them, then we get 15. So like this, you see B and C bit. 3 number. Write the greatest prime number less than or equal to the following numbers. Children, you follow that grid, okay, which are prime and which are composite number, easily you can find. So 59 is the one prime number. Okay, so 59 equal to 59. Then you check 101, then 96. 4 number. Write all the multiples of 5 between 30 and 50. You have to write multiples of 5 which are between 30 to 50. So between 30 to 50, 35, 40, 45. Okay. So like this you write B bit. Then 5 number. Can the product of two prime numbers be prime? If yes, then give an example. Children, here answer will be no. The product of two prime numbers is always a composite number. For example, 5 7 ja 35, 2 3 ja 6. Here 35 and 6 both are composite numbers. Then comes to 6 number. Are 27 and 72 co-primes? No, as they have common factors. Okay. Then comes to 8 number. How many even prime numbers are there in the set of natural numbers? List them. Children, here your answer will be only one, that is 2. 9 number. Write all the pairs of twin primes less than 20. Also find whether 49 and 51 are twin primes or not. Children, these pairs you prepare yourself and 49 and 51 both are composite number. They are not prime number. So, they are also not twin primes. Then 10 number. Write 5 pairs of co-prime numbers. Co-primes you can write 2, 3, 3, 4, 5, 6, 7, 8, 11, 13. Then 11 number. Write the multiples of 23 between 80 and 180. Here children, you have to write multiples of 23 and which are between 80 to 180. Children, in 23 table, 23 fours are 92. So you start from 23 fours are. 23 fours are 92, 23 fives are 115, 23 six are 138, 23 sevens are 161. So 92, 115, 138 and 161 are the multiples of 23 and which are between 80 to 180. Okay children, clear this exercise 3.1. Before you start this exercise, you read all the important terms. Okay, and also remember which are prime numbers 1 to 100. So this is your homework. You do it in your copy. Thank you.